Good morning, everybody. Welcome back, and happy Friday to you. This is the homework assignment over here. You can stop it and look. It's also on Noodle, of course. So what we're going to, this video is about is section 1.3, average rate of change. And so that's what we're going to be talking about. Let me erase this board over here, homework assignment, and then I'll erase the other one, and let's go. Happy Friday. Okay, average rate of change. Come on, right there. Rate of change. Now we've been talking about functions quite a bit, and so this is all about functions. So I'm going to actually draw a picture. Let's do this with pictures. There's something that starts there and winds up there. Who knows what it is? Maybe this point is -2, -4, -1 or something, and this point is 7. 7 and 5. I don't know. And so what all we're saying is, how much does it change this way? Change in y as it changes this way. Change in x. So the average rate of change is defined as average rate of change. Change in y over change in x. This is quite common notation. Change in y over change in x. Over change in x. Calculus is based on this ratio. What happens? We're going to get an average rate of change over an interval, but what happens in calculus, they squeeze that interval to nothing. So the change in x is nothing, and then we call it instantaneous change. And that's where calculus is born. So anyway, here we go. Right here. Change in y over change in x. Here, formula, y over change in x. The change in the range divided by the change in the domain is, well, the range, it went from 7, it went from down here at -1 all, up to 5. That's the change in the range. 5 minus -1. It changed 6 units from here to here. And then the domain, on the other hand, that's the 7 minus -4, which is 11 units. So here, the average rate of change for that picture is the change in y's, 5 minus -1, over the change in x's, 7 minus -4, which is 6 over 11. The average rate of change of this particular function, this picture, is 6/11. All we're saying is, as this incrementally increases by 1, this incrementally increases by 6/11. As it goes from here to here, the average rate of change, as this incrementally increases, is 6/11. That's what it is. It's just change in y over change in x. Another example. No, that's good enough. Looking at the page. Average rate of change. While I erase. This is, I cannot emphasize the importance of this in terms of calculus. What you're studying right now is pre-calculus. I mean, you have to get prepared for calculus. The rate of change, the whole system's based on rate of change. All of calculus, even higher level mathematics. Okay, I'm proselytizing, man. Ooh, that's pretty good. Another example or what? Oh, here we go. So we have the average rate of change. Let's do that one right there. How about example f of x? Because this is a toolkit function, let's do f of x equals x cubed on what do I have here? I have all those written down. -1. No. -1, 2. Okay, that's the question. What's find the average rate of change? Determine. Quiz question. Average rate of change. Sorry about that. And so here's the picture of it. You don't need the picture, but this is a toolkit function. So there's f at x equals x cubed. And so all we're saying is it starts here, -1, and it goes to here, 2. That's how far we want to find, we want to figure out how average this function is changing. And now really at -1, that point is actually -1, -1. So right there is f at x, f at -1. And this point here, oh well, it should be way up, sorry about that, is to 8. Right there is f at x. F at 2 equals 8, f at -1 is -1, so change in y over change in x, if you will, is 8 minus -1 over the change in x's. Well, I went from 2 to -1. 2 minus -1, 8 minus 9/3, or 3. We're saying, as it goes 3 units this way, the average rate is 3 units that way. Now, I'm sorry, that point should be, I should have drawn it a little more drastically. But there we go. So average rate of change. It can also be an expression, t squared plus 3t plus 1 from 0 to a. By the way, as I say, the average rate of change is really important because this could be time. And so what we're saying is, here's an expression, I don't know where it came up from, but it starts at time 0 and goes to time a. So f at a would be a squared plus 3a plus 1. F at 0 is 1. And so the change in y's, which is f at a minus f at 0 is a squared plus 1 minus 1. 3a plus 1, that's f at a, minus 1, over change in x's, which is change in x's, which goes from a to 0, a minus 0, a. And so the change in x's over change in y's is this expression here, a squared plus 3a plus 1 minus 1, a squared plus 3a. This one here, a minus 0, is a. You can factor the a out because it cannot be 0 because it's an interval, so it's a plus 3. Boom. Everything we're saying is this function changes a plus 3 times every time we incrementally increase it from 0 every second. If t is time, every second. This is changing a plus 3 times. Stop. Hey, we got a little bit more to go in this section. It'll be I'm trying to keep them as short as possible. This is 8.5 minutes. Adios.